Good afternoon. Am I audible?
Yes,
Yes,
sir.
sir.
So we will get started. Yeah. So I think this was the last topic we discussed, right? Total internal reflection. Phenomenon of bending back of light into the same denser medium when the angle of incidence is greater than the critical angle. Right? So was this the last concept?
Yes, sir. Yes, sir.
Now we'll proceed. Did we do any problems based on this topic?
Yes, sir. We did a few questions. Book back. I think.
We did few questions, right? Okay. What about questions based on real depth and apparent depth?
I don't think we did for real depth and apparent depth.
This one, this assignment did we do?
We did till 7th one, I think, sir.
We did till 7th, right? The apparent depth of an object. Do you remember seeing this kind of a problem? The apparent depth of an object at the bottom of a tank filled with a liquid of refractive index 1.3, 7.7. What is the actual depth of the liquid in the tank?
Actually, I'm not sure, sir. This is the question we did.
So there is the question. There is a ray of light of frequency 5 into 10 power 14 hertz is passed through a liquid. The wavelength of the light is measured inside the liquid is found to be 450 into 10 power minus 9 meter. Calculate the refractive index of the liquid. So how to solve this? So what is the relation between speed and refractive index? Mu is equal to
C by V.
C by V, where C is the speed of light in vacuum divided by V. So what is the relation between speed with fourteen? Correct? This is right. So on solving this, you will get the answer as 4 by 3. You can try and see, you will get the answer as 4 by 3. So 4 by 3 is going to give you 1.33. So just give me a confirmation, guys. Is it clear?
Yes, it's clear, sir.
Okay. Second, a light of wavelength 6000 angstrom in air enters a medium with refractive index 1.5. What will be the wavelength of the light in the medium? So what is the relation between refractive index and wavelength? The refractive index is directly proportional to,
Wavelength,
sorry,
sir.
is it not inversely proportional? Yes, it is inversely proportional to wavelength.
Sir, I have a doubt, sir.
I made a mistake. So mu is equal to, sorry, I made a mistake. Mu is equal to same logic, C by V. So C is lambda 1 into F1 divided by lambda 2 into F2. So here one important point to be noted is when the light travels from one medium to another, its frequency will not change. Okay, because the frequency is a characteristic of source. So lambda 1 by lambda 2. Lambda 1 is 6000 divided by lambda 2 is equal to 3 by 2. Cancel this. It will go 2000 times, which implies lambda 2 is equal to 4000. Rohan, you were asking some doubt. What is it?
Yes, sir. It was this only. I thought we could express C as lambda into frequency.
Yes, you can do that. But here, the important point to be noted is please everyone make a note. When light is traveling from one medium to another, frequency will not change. There's an often asked 1 mark question. Please make a note of it. Frequency will not change when light is traveling from one medium to another. And what is the reason for it? Reason is frequency is a characteristic of the source.
So, sir, that means the source of both C and V are the same, sir.
Guys, I'm sorry, there's some network issue. So what was I telling?
You explain why frequency won't change.
Yeah, frequency because it is the characteristic of source. So what is the source generating light? It is the accelerated charged particle. Correct? So whatever is the frequency with which the charged particle is accelerating, the same frequency will be for the light as well. So what I'm trying to say here is when light is traveling from one medium to another, its frequency will remain constant. But speed and wavelength will change in such a way that the ratio of both will have a constant frequency. Are you able to understand?
So, I have a doubt, sir.
Not able to hear. Okay, let's do the third one. The refractive index of glass is 1.5 and that of water is 1.3. If the speed of light in water is 2.25 into 10 power 8 meters per second, what is the speed of light in glass? So refractive index is inversely proportional to speed of light. So 1.5 divided by 1.3 is equal to V2 by V1. What is V2? V2 is what you need to find the speed of the light in glass divided by the speed of light in water is 2.25 into 10 power 8. So what is the speed of light in glass? It is going to be 1.5 divided by 1.3 into 2.25 into 10 power 8 meter per second. So on solving this, you will get this answer. If I'm audible, just give me a confirmation. Am I?
Yes, sir.
Yes, sir.
Okay. Okay. So next one, fourth one. There is a ray of light that passes through a plane boundary separating two media whose refractive indices are mu1 is equal to 3 by 2 and mu2 is equal to 4 by 3. If the ray of light travels from medium 1 to medium 2 at an angle of incidence 30 degrees, what will be the angle of refraction? So there is a problem based on Snell's law. So apply Snell's law. So there is a boundary. Ray is traveling from the medium of refractive index 3 by 2 to 4 by 3. And what is the angle of incidence? The angle of incidence is 30 degrees. If that is the case, what is the angle of refraction? So how to solve this?
mu1 by mu2 equal to sin A by sin R, sir.
Or else we can write, I told you an easier way, right? Refractive index multiplied with sine of the angle in that medium, that is sine 30 degrees is equal to 4 by 3 into sine R. So sine 30 is half. 3 by 4 is equal to 4 by 3 into sine R. So sine R is equal to 9 by 16. So R will be equal to sine inverse of 9 by 16. So what is the answer for the second part? You will get sine inverse of,
4 by 9, sir.
is it not 8 by 9? Check. Because you will have 4 by 3 into sine 30 is equal to 3 by 4 into, or 3 by 2 are there.
It should be 3 by 2, I think. Be 4 by 9.
3 by this, 8 by 9 is equal to sine R. Sine inverse of 8 by 9. Go and check it. Correct? No. The fifth one. There is a rectangular glass slab which rests at the bottom of a beaker. A ray of light incident on the water surface at an angle of 50 degrees, we'll make it 30 for the time being. 30 degrees passes through water into glass. Calculate the angle of refraction in the glass, given that the refractive index of water is 4 by 3 and that for glass is 3 by 2. So when you take the glass surface, the refractive index of the glass is 3 by 2 and the refractive index of the medium outside is 4 by 3. So what is the angle of incidence? 30 degrees. So when it is 30 degrees, you need to calculate the angle of refraction inside the glass. So 4 by 3 into sine 30 degrees is equal to 3 by 2 into sine R. So sine R will be equal to 8 divided by will be sine inverse of I have a lot of network issue today. So there is a ray of light which is just incident at an angle of 60 degrees and on one face of a rectangular glass slab of thickness 0.1 meter. The refractive index is 1.3. Calculate the lateral shift produced. Just give me a minute. I'll try to connect it to an alternate device. You guys try solving this problem, sixth one. Yeah. Now it will be more stable, guys. Yeah. So what is the answer for the sixth one? There is a ray of light which is incident at an angle of 60 degrees on one face of a rectangular glass slab of thickness 0.1 meter and refractive index 1.5. Calculate the lateral shift produced. So how are you going to calculate it? So what is the formula for it? Last class I derived it, right? So this is the one. T times sin I into 1 minus cos I divided by root of mu square minus sin square I. Correct? T sin I into 1 minus cos I divided by root of mu square minus sin square I. That is the case. What is the value of I? 60. Thickness 0.1 meter. Refractive index 1.5. Substitute everything here. You will get the answer as this value. Okay. Seventh one. So how to do the seventh one? The apparent depth of an object at the bottom of a tank filled with liquid of refractive index is filled with refractive index 1.3 is 7.7. What is the actual depth of the liquid? So what is the relation between real depth and apparent depth? Real
H
depth
dash
is
equal
equal
to H by U.
apparent depth divided by mu. So apparent depth will be equal. Sorry. Apparent depth is equal to real depth divided by mu, which implies real depth will be equal to apparent depth into mu. So what is the value of apparent depth? 7.7 into mu is 1.3. So it should be 10 point something. So this is the answer. Okay. So there's all some kind of problems which are based on the concept of real depth and apparent depth. Okay. So with this in mind, we will move on to the next chapter, next topic, that is refraction through spherical surface. So write it down. So for refraction through spherical surface, we'll take a surface like this. Okay, till now, we were seeing refraction at a plane boundary like this. Right. Now we'll see what is going to happen when there is a refraction taking place at a spherical boundary. Is that clear? So for which we are going to take a point object. So let's say there is an object which is placed after the center of curvature. Okay, you have the pole. So this is the place where the object is kept. Now let's say this side refractive index is mu1, the other side refractive index is mu2. So from point O, there is going to be a ray like this. right? So I'm saying mu1 is less than mu2. So what will happen? mu1 is less than mu2 means mu1 is rarer medium and mu2 is denser.
Denser.
So when ray is traveling from denser to rarer, it is going to bend towards the normal, right? So at the point of incidence, what are we supposed to do? You draw a normal line. So this is going to be the angle of incidence, right? And this is going to be the actual path. So when this is the actual path, then the ray will start bending towards the normal, something like this. Am I clear, guys? So what will happen is, this is one ray, and you take another ray along this so-called principal axis itself. So when you take it along the principal axis, what is going to happen? It will travel without any deviation, because what is the angle of incidence? Angle of incidence is 0 degrees, and the angle of refraction will also be 0 degrees. So these two rays, when you back trace them, this is the point where the image is formed. Am I clear with this?
Yes, sir.
Right. Just give me a minute. I'll draw a better diagram for you to understand. The diagram is a little cramped. Yes. So the curvature is like this. I take this as point O, then this is the point where the object is hitting the surface. And at the point of instance, you're going to draw a normal. So at the point of instance, draw a normal like this, which is through the center of curvature. And this would be the actual path. So the ray will start bending like this, as a result of which you will get the image formed here. Clear? So because the ray will start turning in the anti-clockwise direction. Right, this is where the image is formed. And if I take this point as P, this is mu1, this is mu2, ray is traveling from rarer to denser. Okay. So the distance from point P to O is what we call it as U. And the distance from P to I is called as V. And the distance from P to C is called as R. Okay. Right. Now, this is going to be the angle of incidence. And this would be the angle of refraction. Right? Any doubt till this point? Any doubt, guys?
So what is I?
I is the angle of incidence. I is
No.
capitalized the point where image is formed.
Okay, sir.
Yeah. I'll make it. So this is the thing which might slightly confuse you. Red color line is normal, and this blue color line is the bent path. Okay, is this better now? You're able to understand? See, this derivation is slightly tricky, so please concentrate. Before we start, I need to mention certain points. So points to remember. First, angles considered are very small since the rays are paraxial. Okay. Angles considered are very small since the rays are paraxial. And secondly, aperture of the surface is very small. Okay, wow. So this is going to be alpha, this is going to be beta, and this is going to be, let's say, this is theta. Guys, are you able to understand or not? If it is tough, I will change the scenario. We need not change the concept. If you're not clear with the diagram, I'll change the scenario and make the diagram more easier. You're able to understand or not?
Yes, sir.
Everybody?
Yes, sir.
Okay. So, if this is the case, then tell me what is the relation between, I take this point as A. Okay. Tell me, if I take the triangle A, O, and I, A, O, I, this is theta, this is beta, then how much is this angle? If this is R, how much will this angle be? This will also be R only. Am I clear? So if it is R, what is the relation between all these three angles? Beta will be equal to theta plus R. Correct? So which implies R will be equal to beta minus theta. Let this be equation number 1. Any doubt in this step?
No, sir.
Good. Very good. Okay. Now I am taking the bigger triangle AOC. AOC. If this is theta, then this is alpha, then this is going to be I. Accepted? So what is the relation? Alpha will be equal to theta plus I. So I will be equal to alpha minus theta. Equation number 2. Now applying Snell's law at point of incidence. So if I apply Snell's law at point of incidence, I'll get mu1 into sin I is equal to mu2 into sin R. But what did I say? Angles are small. Since angles are small, mu1 into I will be equal to mu2 into R. So mu1 into, what is the value of I, guys? Beta minus theta is equal to mu2 into, what is the value of R? Sorry, alpha minus theta, right? Are you able to understand where I'm substituting from? I is alpha minus theta and R is beta minus theta. Right? So mu1 into, in the place of alpha, I can write it as tan alpha minus tan theta is equal to mu2 into tan beta minus tan theta. Can someone tell me why I wrote it like this? So how can I write the angle as tan alpha? Because the rays considered are paraxial and the angles are small. So till now, what did we do? Wherever tan alpha was there, you approximated to alpha, but I'm using the reverse case. So when I do that, mu1 into, what is going to be the value of tan alpha? Tell me. Looking at the diagram, what is going to be tan alpha when AP is 90 degrees? So tan alpha will be equal to AP divided by
CPs.
that is R. Similarly, what is tan beta equal to?
AP
AP
by
divided
V.
V. Tan theta will be equal to,
AP divided by U.
that's it. Have these things in mind. And you need to substitute it with sign convention. So minus, minus, and minus. Okay. So tan alpha is AP by minus R minus tan theta is how much? AP by minus mu is equal to mu2 into tan beta is how much? AP by minus V minus what is the value of tan theta? AP by minus U. I think there is a mistake in the diagram. Let me check it. So AP will get cancelled. Okay. So you will get minus mu1 divided by R plus mu1 divided by U is equal to minus mu2 divided by V plus mu2 divided by U. Is it right? So 1 minute guys, don't copy it. So mu2 by V minus mu1 by U should be equal to mu2 minus mu1 divided by R. There is a mistake. I'll tell you where the mistake is. Okay. Now I want you guys to work with me. I found the mistake. Can you tell me that there is a mistake in the angle that I have taken?
R should be R, sir, an angle R.
Yeah, where should R be?
R should be in the lower part, I think. So.
So that is right, because that is where I had a doubt. Because, see, observe, where is R here? R is between the refracted ray and the normal. So when the refracted ray is back traced, that is where the image is formed. So this is the back traced refractive part. Correct? And this is the normal. So for normal, I will use a different color C. This is the normal. So where should it be? It should have been here. Right. So for me to involve angle R, I should have taken the triangle A. I should have taken the triangle. Can you tell me which triangle I should consider? A, I, and C. I hope nobody has copied it. So we have to change this part. This is R, this is beta, this is alpha. So what is the value of, what is the relation? Alpha is equal to beta plus R, which implies R is equal to alpha minus beta. This is 1. So R is equal to alpha minus beta means I should change it here. Alpha minus beta. All other things are okay. No changes in them. So alpha minus beta. So this is tan alpha minus tan beta. So what is tan alpha, guys? Mu2 into what is tan alpha? AP divided by minus R minus AP divided by tan beta is going to be minus V. If you want, you can check it. I will get the right answer. Guys, I hope it is clear, right? Is there any step that is confusing you? So AP gets cancelled. Minus mu1 by R plus mu1 by U is equal to minus mu2 by R plus mu2 by V. So mu1 by U will go to the other side. Mu2 by R will go to the other side. So mu2 minus mu1 divided by R is equal to mu2 by V minus mu1 divided by U. This is what we call as the formula for refraction at spherical surface.
So can you go up, sir, for a minute?
One minute, I'll turn the page itself. Page maker.
So a bit more up could you go, sir, to the diagram part?
Yeah. Concept is clear for everyone, right?
Yes, sir.
Let me know once you're done. See, I suggest everybody to write it. Don't take a screenshot or something. Sit and write, only then you're going to understand. That is the reason I've given you time. Copy it, guys. Done?
1 minute. Done, sir.
You're done?
Yes.
Everybody is done? Okay. So, this is what we saw, refraction at spherical surfaces. So this is what we saw, but here the diagram is slightly different. Okay, let's see how to solve a problem based on this concept. So you would have understood in all the derivations, what did I tell you? You need to apply sign convention during the process of derivation, and you need to apply sign convention while solving the problems also. So listen. Light from a point source in air falls on a spherical glass surface whose refractive index is 1.5 and radius of curvature is 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what position is the image formed? So light from a point source in air falls on a spherical glass surface. So here they should have given one thing. Is it going to be curved? What kind of a curved surface? Okay, on a spherical glass surface, and this thing, the distance. So, radius of curvature. See, actually, the question is ambiguous. Okay, because the object is kept on this side, accepted, but there is a possibility of the spherical surface to be like this, or there is a possibility of the spherical surface to be like this also. Okay, so I am assuming that it is like this as of now, but they are not light from a point source and also a spherical glass surface. Spherical. Okay, so the spherical glass surface, let's take it like this. So what is the value of u? Minus 100 centimeter. Radius of curvature is plus 100 centimeter. They are asking v is equal to what? So what is the formula base? This is mu2, this is mu1. So refractive index of second medium, mu2 divided by v minus mu1 divided by u is equal to mu2 minus mu1 divided by r. Are you able to understand what I'm trying to do? So mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. Guys, did you understand? Mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. So mu2 divided by mu2 is how much? That is the refractive index of the medium in which the refraction is taking place. That is 1.5, this medium, divided by v is how much? That's what we need to find. Minus mu1 divided by, what is the value of u? U is minus 100 is equal to mu2, sorry, mu1 is 1 because it is air medium. Mu2 minus mu1 is 0.5 divided by r is 20. So 1.5 divided by v is equal to 1 by 40 minus 1 by 100. So it is going to be minus 60, not minus 60, plus 60 divided by 4000 is 1 by v. So v will be equal to 400 divided by 6. So 400 divided by 6, whatever is the answer, that is the answer. There's 1.5 left. Made a mistake. So it is 3 by 2v. So 3 divided by 2v means this is going to be 200 times. And this will be 2 times. So 100 divided by 2. Sorry, 200 divided by 2, which is going to be 100 centimeter will be. That will be the answer. And it has come out as a positive value. So the meaning of positive value is object is on the left hand side and the image is formed on the right hand side. But did you understand the problem?
Yes, sir.
Right. So let us concentrate on this one. If this concept is clear, the remaining concepts are very simple. So let's try to solve another problem which is based on this concept. or textbook problems. Okay. Anyways, I have an assignment based on which we'll solve it in next class. So, if this concept is clear, we will see how the refraction is taking place within the lens. Okay. So, basically, what does lens mean? Lens is a refracting surface with at least one surface being spherical. So basically, if someone asks you what does a lens mean, lens is basically a refracting surface where at least one of the surfaces is spherical. It is not necessary that both the surfaces are spherical. Okay. So having this in mind, we will see how the refraction is taking place at this kind of a lens. Shall we get started? So what lens is this? So this is basically a biconvex lens. Okay, listen to this. So figure 9.18a shows the geometry of image formation by a double convex lens, or we can call it as a biconvex lens also. So the image formation can be seen in terms of two steps. The first refracting, so we will see it in two steps. Okay, so what I'm going to do is, this convex lens is there, right? It is broken into two parts. So when you break it into two parts, what is going to happen? This is one of the refracting surfaces, and this is one of the refracting surfaces. So there are two refracting surfaces which are taking what shape? Are they plane or spherical? So with respect to this lens or a convex lens, what is going to happen? Both the surfaces are going to be spherical in nature. Guys, I'm not able to shout too many times. Okay. Please respond. Are you able to understand or not? I need an yes or
Yes, sir.
no.
Yes, sir.
Yes. So, yes. So when I am asking a question, please try to answer. Or else I'm losing motivation. I can't teach. Listen. How many refracting surfaces are there? Two. Right? So the two refracting surfaces, both the refracting surfaces are what? They are spherical. Accepted?
Yes.
Yes,
What
sir.
is going to, so what is going to happen here is, listen to this very carefully. Okay. So at the first refracting surface, if I draw something like a free body diagram, means if I break it into small parts, that is, if I break it into two parts, this surface is there, right? This surface AC, the object is kept here. Accepted? So when the object is kept there, what kind of an object? It is a point object. Now, the ray is traveling in this way, and this is the normal. Okay. So what is it? It is the normal, which is going to pass through the center of curvature of the first refracting surface. Now tell me, the ray is traveling from mu1 to mu2, and it is traveling from rarer to denser medium. So when it travels from rarer to denser medium, what will happen to it? The ray will start bending towards the normal. So when it bends towards, yes, when it bends towards the normal, it is assumed, see, I'm using this word, I'm stressing on this word, it is assumed that the image is formed inside what? Inside the glass medium. At which point? At point I1. Is this diagram clear?
Yes, sir.
Yes. Now, there are two possibilities. So, I just have to stress on this point for you to understand it. If I take the same diagram, see, if I take the same diagram, try to understand this. If the object is placed here, this is the incident ray. And at this point, if there is going to be the center of curvature, the ray is traveling in this actual path. So when I say the ray has got bent, so you need minimum two rays, right? One of the rays you will always take along the principal axis, which will travel undeviated. So in the scenario that they have shown in the textbook, the ray is bending more towards the normal. So when I say it is bending towards the normal, it can go like this also. You're able to understand? Means it is slightly above than the surface being parallel to it. So if I take parallel, it is going to be like this. Now tell me, will this refracted ray and the second refracted ray along the principal axis, are they going to meet?
No, sir.
They are not going to meet for sure, right? So this is one of the possibilities where when the ray is traveling from rarer to denser medium across a boundary which is curved can happen. So when you have a curved surface, on the left of the curved surface you have what medium? Rarer medium. On the right you have a denser medium. So the image can either be a real image. So with respect to refraction, what does real image mean? Real image is when the object and image are on either side of the refracting surface, then it is a real image. Okay. So it can either be a real image or a virtual image. So the diagram that is shown here, the diagram this is shown here is only an approximated diagram and it is our guess. So what is happening? There is an image which is formed on the principal axis is what they are assuming. Right? Are you clear? So the meaning
Yes,
of this
sir.
diagram. Now what will happen is this image that is formed, it is formed in which medium? Look at the colors. So blue color is used for glass medium. They are assuming that this is formed within the glass medium itself. And this image will start acting as the object for whom? It will start acting as the object for the second refracting surface. Right? Whereas the second refracting surface is like this. The second refracting surface is like this. Okay. Are you able to understand? Now see, this image I1 is there, right? Which is formed on the right hand side. So this image is going to act like a virtual image with respect to the second refracting surface, due to which it is assumed that the final image after undergoing multiple refraction is formed at point I1. So I'll explain how they have drawn it. So the second refracting surface is like this. So if I take this to be I1, right, this is mu1 and this is mu2. So the ray kind of travels like this and it is going in this way, right? So at this point, you will have this as the center of curvature. Now the ray is traveling from rarer to denser again. So it starts bending like this. As it is bending, the image is assumed to be formed here. Okay, this is my assumption. This would have happened. Are you able to understand this point?
Yes, sir.
Yes.
So if you see their diagram, this I was on this side. So what is the important conclusion that you're able to draw from here? The diagram that is given in the textbook or the diagram which I'm drawing are only an approximate guess. Here, the important concept that you need to have in your mind are 2 points. What is it? The ray is undergoing 2 refractions at 2 curved surfaces. And secondly, the image formed due to the first refracting surface is acting as the object for the second refracting surface. Is that clear? So keeping this point in mind, the derivation is going to be very, very, very simple. Okay. Observe what it is going to be. So as I told you, this is an approximate diagram. Till now, I would have mentioned that whichever derivation you do, you need to apply sign convention. But when you're applying problems, I told you another point also. Whichever is an unknown, don't apply sign convention to it. Right? Having these 2 points in mind, what I'm trying to say is, this whole diagram is an approximate diagram. So nothing is known to us. So this is the derivation where you will not apply sign convention at all. Okay. So refractive index of the outside medium here is mu1, here it is mu2, and this is V and this is U. Now apply refraction at spherical surface for the first boundary. What is it going to be? Mu2 divided by V. So mu2 is the refractive index of the medium in which the image is formed, minus mu1 divided by U. So mu1 is the refractive index of the medium in which the object is kept, is equal to mu2 minus mu1 divided by r. So mu2 minus mu1 means mu2 is the refractive index of the medium where the image is obtained, and mu1 is the place where the object is placed. Am I clear with this? So this is the formula for the refraction at the first spherical surface. So instead of taking r, I will call it as r1, because we are assuming that the radius of curvature of both the surfaces is not the same. So that's why we can call it as a double convex lens also. Right. In a similar way, if I apply the refraction at spherical surface for the second boundary, then something divided by v minus something divided by u will be equal to something divided by r2. Okay, one small correction. In the first equation, mu2 divided by v1 minus mu1 by u is equal to mu2 minus mu1 divided by r1. Because I didn't write it as v, because v is the location of the final image. Okay. Now, if I take this as v, then this distance from the pole to I1 will be v1. Now you tell me, guys. So mu2 divided by v minus, sorry, not mu2, something divided by v minus something divided by u1 in the case of the second refraction is what?
V1, sir.
Yes, it is v1 is equal to something divided by r2. Now you need to be clear. Where is the object placed according to the second refraction? The object is placed in the medium in which the first image was formed, in which the image due to the first refraction took place. So first, due to the first refraction, where did the image take place? In
The glass.
mu2. That is mu2. So this is the important step you need to have in your mind. Did you understand why I wrote mu2? Because mu2
Yes,
is where v1 is formed. Now, where is v formed? It is formed in the air medium. That is mu1. So that one we will substitute it at the end. So by R2, R2 means what? Mu1 minus mu2. Guys, did you understand? Here mu2 by v1 minus mu1 by u, right? So right hand side, if you see, it is mu2 minus mu1. So first refractive index minus second. So in the second case, it will be mu1 minus mu2. These are the two crucial steps of this derivation. I'll call this as equation number 2. Now, when you add both these equations, what is going to happen? Now, when you add these two equations, what will happen? Mu2 by v1 and mu2 by v1 will get cancelled. So let me finish this, then we can end the session. So what has happened? Mu2 by v1 minus mu1 by u is equal to mu2 minus mu1 divided by r1. Similarly, mu1 by v minus mu2 by v1 is equal to mu1 minus mu2 divided by r2. Now, when you add both, this and this are gone. So mu1, if you take it out, 1 by v minus 1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. Okay. Taking mu1 to the other side, you will get 1 by v minus 1 by u is equal to mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. Listen to this carefully. 1 by v minus 1 by u according to length is 1 by f is equal to mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. And there is a name for this formula which we call it as lens maker's formula. Okay. So have this in your minds. Okay. This part alone, just take a screenshot. In tomorrow's class, we will do some problems based on the previous two concepts. Just take a screenshot as well. Okay. So tomorrow's class, we'll be doing problems based on refraction at spherical surface and lens maker's formula. These two are very, very, very important concepts because most of the questions come from these two concepts. Okay. So we'll do them tomorrow. I hope it is clear, right? Other parts are clear.
Yes, yes,
Yes,
yes.
sir.
Okay. I'll see you tomorrow. That's it from my side for today.
Thank you, sir.
Thank you,
Yeah.
sir.